So section 6.2 is talking about the properties of parallelograms. So by definition, we can say that a parallelogram is a quadrilateral with two pairs of opposite sides. Okay, this is by definition. Now, the symbol is just like a little rectangle. That's the symbol. And we have four properties. The first one, opposite sides are congruent. The second one, pay attention because I'm going to ask who knows the four of them, okay? So the first one, opposite sides are congruent. The second one, opposite angles are congruent. The third one, consecutive angles are supplementary. Consecutive means what? What is consecutive? Next to each other. That's right, next to each other. That's consecutive. Okay? So consecutive angles are supplementary. Supplementary means?
They
Equal to 180. And the last one is diagonals bisect each other. What's meant by bisecting? They cut each other in half. Okay? Cut in half. Okay. So, who can tell me the four properties without looking at? Okay, so with those four properties and one definition, let's answer question number 1. And we're going to have to justify, okay? In parentheses, we're going to justify the answer. Justify answer. Yes. I choose the color on the bottom. Yes. Okay, so then AB. If I want to know AB, AB is parallel to CD. So how much is AB? 10. So it's 10 centimeters. And let's justify it. Opposite sides are congruent. Perfect. How about number 2? The measurement of angle D. How much would that be? Angle D. 70 is right. How did you get the 70, Andy? Okay, so it's consecutive angles are what? Supplementary. Okay, so if they're supplementary, that means that 180 subtract the 110, and that gives you the 70. Okay, so that is 70. Good job, Andy. Now, number 3. ML. Let's justify that. So, justify the answer. 12? Okay, so ML is 12. You're right. And how come that is 12? Opposite sides congruent. Perfect. How about LP? How much is LP? That is 10. And what's the reason for that being 10 meters? Also, opposite sides congruent. Perfect. What about the measurement of LMP? Okay, L, P, and M. That is 62. You're right. That is 62 degrees. And why? How come that's 62 degrees? We learned this lesson. How do you call those angles? Alternate interior angles. That is right. The lines are parallel lines, and that implies alternate interior angles. Okay. Now, how about number 6? LN. LN is this segment. How much is LN? 18 is right. 18 meters. How do you determine that was 18 meters? Diagonals,
Circle.
right? Diagonals bisect each other.
Oh my
Opposite angles
God.
congruent. How about number 7? Angle L, MLN, MLN, MLN. 32 is right. That is 32. How come that is 32? Because the lines, these two lines are parallel, and those two angles, therefore, are alternate interior angles. That's right. So it's 32 degrees. The lines are parallel, so it's parallel lines, and is by alternate interior angle. So you could use alternate interior, corresponding, same side interior. All that we learn about parallel lines, we can implement it here. And the last one, number 8. How about QN? That is 9. You're right. How come that is 9? Because diagonals bisect each other. Okay, perfect. So that is when you just have to find measurements of sides. Okay, so now let's move on to the second part. Okay, so now that we know those basic rules, let's find out what is CD in number 9. It says CDEF is a parallelogram. So I already know that it's a parallelogram. Therefore, what I can say is that opposite sides are parallel by being a parallelogram, by definition. So therefore, I can apply those 4 properties. So CD must be congruent to what?
FE.
To FE or EF, right? So those two must be congruent. So here I can say, well, DC, segment DC, is congruent to segment EF. Therefore, what I can do is I can let both of those sides equal to each other, because if they're congruent, their measurement is equal. So, and then we just solve for W. So move the 4 over. So how much is 5W minus 4W? 1W, and then subtract 1 from 8, so W is 7, right? But then on number 9, there one CD, not W. So what do I do? Plug it in, insert. Instead of W, we put 7. 4 times 7 is 28, plus 8 is what, Matthew? 36, perfect. And how about EF? Do I have to plug it in?
No.
No, I know that they're congruent, so we can just say that they're equal. Okay, now what about the measurement of angle F and E? What relationship do they have, those two?
They're
Consecutive angles, and therefore what? They're supplementary. So angle E, the measurement of angle E, plus the measurement of angle F must be 180, which means that 9Z minus 12 plus 3Z equals 180. Okay, let's combine the Z's. So 9Z plus 3Z is 12Z minus 12 equals 180. What else do we do? Add 12 to both sides. So 180 plus 12 is 192, and then we divide it by 12, and that is 1, and 72 divided by 12 is 6, so it's 16. But I want the measurement of angle F, not what Z is. You plug it in. So it's 3 times 16, which is 48. Now what about the angle E? Do I need to go back and plug it in? Or can I do something shortcut? Subtract, right? So subtract what? 48 from 180, and that gives me the supplement, which is 132. Perfect. 132. Questions about how to find missing pieces, just sides, or using algebra to find missing pieces. So far, so good. Now for number 13, we're going to go ahead and get let's plot those points. Okay, so number 13, let me plot those points. It seems like this is in the first quadrant. So it's 0, 6, 1, 2, 3, 4, 5, 6. This is point A. Point B is 5, 8. 1, 2, 3, 4, 5, 7, 8. And C is 5, 5. 5 and 5. Now, I know that when I connect A to B to C, the next point should be D. And that's the one that is missing. That's the fourth vertex. So would D, this is C. So would D be on the left of C or on the right of C? Left, right? It has to be somewhere here, right? So that we can go like this. Okay, so this I know is parallel to this right here. So let me find out how many units I need to go on the slope, because if the sides are parallel, I just follow the same slope. So let's find the slope of BA and then repeat it from C, and we find the point D. So what is the slope of B to A? What is the rise? From 8 to 6. It goes down, right? How many units down from 8 to 6? 2, so it's minus 2. And then to the left on the run, so run, I have to go to the left. 5 units, 5. So let me repeat that. I'm at 5. When I move 2 down, I would be at what number? 3. And then to the left. So point D, it's a 0, 3. So all you gotta do is find out the slope of one side so that the other side is parallel. And automatically that comes after you finish with the second slope, okay? Okay, in problem number 14, you first plot the points. Once you plot the points, when you want to connect the point, see the parallelogram is K, L, M, N, so you have to go in that order. So from K to L, from L to M, and then you have to go to N. So we're missing the N. Now where's the N going to be? Well, it has to be somewhere here, because the parallelogram has to go like this, and then something like that, and then like this. So the side KL must be parallel to the side MN, and the side KN must be parallel to LM. So if I find the slope of KL or the slope of LM, I just repeat the slope from M this way, and that way it's parallel to that, and that would give me. Okay, so the slope of LK, we have to do the rise over the run. So on the rise, I can say that that is 1 up, positive, and then 7 to the left, so it's negative. So 1 up, 7 to the left, so it's negative 70, negative 7. So what I'm going to do is the same thing. From M, 1 up, I'm at 4, and then 7 to the left, that is at negative 2. So the point must be negative 2 and 4. That would be N. So the coordinates of N are negative 2, comma 4. And when you connect those points, you're going to have your parallelogram. So therefore, KL is parallel to MN. And also, if you do it from LM, it's going to be the same, parallel to KN.